All right, ladies and gentlemen, welcome back. It is time to nail it in a huge kind of way. We've just talked about all the new arc or inverse trig function derivatives we just picked up. Let's go ahead and really flesh it out in a bigger kind of way, so we can really get into the derivatives. So we're going to cover a couple examples today, maybe like 2, 3 at tops. All right, one could be enough. Okay, now note, including all the stuff before we get started, I'm really eager. You should have already gone through and have learned all the inverse trig stuff. You should already have your trig derivatives at this point. Chain rule, product rule, quotient rule, power rule. All these things are necessary to actually move forward in the course. So please make sure you guys have it. All right. So they say differentiate, and I wrote down here or typed up what the inverse trig functions we got from the last video. So take a look at the last video if you really want to see the proof of arc sine, and I gave the other four inverse trig functions just so to make it clean. All right, they say to differentiate this. This is no different than any problem we have done. So what do we need to do? Well, we need to, first things first, I'm going to rewrite this as arc tan of 3 to the x plus 1 to the 1/2 power. This is not a derivative. This is just me rewriting it. Remember, sometimes you need to clean stuff up. Okay. Now, we are now going to take our derivatives and hope to goodness we do not screw it up. So here we go. F prime of x. I'm taking the derivative with respect to x. So once again, we're going to have to do chain rule. The outside function is the square root function. So I'm going to do 1/2 of whatever's in there to the 1/2 power minus, because 1 minus 1/2 is negative 1/2, times the derivative of whatever is inside the blob. All right, so what's in the blob? I'm going to write it out here. That's just arc tan. And I tend to write this all the time until I get everything I need to get out. Arc tan of 3 to the x plus 1. All right, and now on the left, what do we end up with? Well, let's see here. We end up with, so this is done. Arc tan, I'm going to black it out. It's done, 3x plus 1. And this is raised to the negative 1/2 power. Now I got to take the derivative of this next piece. And we're going to keep doing this until we do it. Now, do you remember the derivative of arc tan? If you don't, then you need to go back and look at the last video or scroll back a little bit and see where I'll show you. Arc tan is 1 over 1 plus x squared. And it's actually a pretty famous one. You're going to use it quite often in Calc 2. I would get used that's one I would commit to memory. So here we go. This means that this is going to be 1 over 1 plus blah squared times the derivative of blah. Well, what's the blah? Well, that's the 3 to the x part plus 1. Yeah, pretty simple. Okay, now let's go ahead and nail through this one more time. What does this end up becoming? Well, I'm going to write everything down again, right? And this is part of the issue with calculus, is that you spend 90% of the time, I think, rewriting things that you have already done. But that is how you keep good track of things. It's the people who skip steps that, 1, normally get lost, and 2, do a terrible job of communicating what they actually know, so people can't even give them partial credit. I would tell you that skipping steps is just heartache. Don't skip it. All right, now if you remember what the derivative of 3 to the x was, or a to the x is, that's going to be a to the x ln of a, and then the derivative of 1 is 0. I'm not even going to bother writing it because it'll be plus 0, and that's going to add together, so it'll be clean. So this is my derivative. Very, very simple. So it's just another simple, whoop, that's terrible. Did all that to make it all pretty and then write all over it. Pretty simple. That's it. Okay. So, and people always say, well, Resh, why don't you do multiple examples of this? Well, because we've done a cajillion examples. We're just adding another cherry on top. Okay. I would encourage you to always go back through and to look for other things. Come to office hours and I will be sure to look through it, but I'm not going to extend the video any longer than it need be. All right. So, like anything else, if there's anything you guys ever want to talk about, shoot me an email or shoot me the problem. We can discuss it. All right. Again, we've completed inverse functions. Next time up, and just to make sure I'm not losing my mind, the next time up we will be talking about the derivative of log functions. Finally, we have needed a lot of stuff. Chain rule was one of it. All right, so that will be the second half of section 6.4. All right, team. Remember, if you want to go someplace you've ever been, you're going to do some things you've never done. So step outside your boundaries, and you'll be great. See you later.